All right, today I want to talk about tree diagrams. They are useful for a couple of different things. They are useful for constructing sample spaces, and they are very useful, or can be useful, for calculating probabilities. All right, so let me talk a little bit about a tree diagram. Let me give probably about the most basic one that I can think of. The most basic one I can think of has a procedure where we only take that procedure and do it one time, and we record the outcome. And we're going to flip a coin. We're going to assume it's fair. And the tree diagram here looks very simple, just like that. So I end up with an H, I end up with a T, and this piece of real estate over here, that's my sample space. So I'm going to run through a couple of examples of these because they can help us understand where some of the things that we've been working with come from. And we can also see that while it does help us understand some very basic detail, there is a lot of things that we cannot do with a tree diagram. They are truly very limited in the scope of problem they can solve. So let me come back and show you how these can be used to calculate probabilities and construct a sample space. This time we're going to do our coin flip 2 times. It's a fair coin, so the probability of a head on any one flip is 1/2. The probability of a tail on any one flip is 1/2. It's a fair coin. So we're going to flip the coin 2 times. I flip the coin a first time. I could end up with a head or a tail. And then after the first flip, I come here and I realize I can flip my coin a second time. And again, we have H and T. This is if I get a head on my first flip, H and T. If I get a tail on my first flip. Now, if one walks along the path there, one comes up with HH, HT, TH, TT. There is the sample space for a coin flip, a double coin flip. I'll probably do one more of these and you'll see why it's somewhat limited. But this one's a good one to point out that we can place probabilities in here also. 1/2, 1/2, 1/2. So for example, the probability of getting 2 heads in a row. What's that probability? I can take the 1/2 and the 1/2, and I remember that coin flips are independent, so the probability of 2 heads is literally 1/2 times 1/2, or 1 out of 4, which, if you've seen some of my other videos, we've been working with the sample space, but we've been coming up with that in a slightly different fashion. The probability of a head and then a tail, 1/2 times 1/2, 1/4. Because we only have 2 coin flips and the coin is fair and the flips are independent, we get the same calculation 1, 2, 3, 4 different times. I will point out that because we've got probabilities here, and this is my sample space, the sum of those probabilities is 1. 1/4 plus 1/4 plus 1/4 plus 1/4. So flipping a coin 2 times, you can see how you might want to use this. I'm going to do this one more time for 3 coins. And at that point, we can understand why the process is very, very limited. It is truly one of scale. So I've got to flip my coin 3 times. I've got a first flip, I've got a second flip, and I've got a third flip. I have heads and tails, heads and tails, heads and tails, and then one last time, heads and tails. And again, it works the same way. You follow all that along, and you'll end up with H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, and T, T, H, and finally T, T, T. But you can see that if we had 4 coin flips, it becomes very problematic in trying to draw a tree diagram. But it can be useful in coming up with a sample space. It also can be useful in coming up with the complete number of items in your sample space. So if I take a look at Mr. Sample Space over here, there are a total of n equals 8 outcomes. For the first flip, I have 2 choices. For the second flip, I have 2, and for the third flip, I have 2. 2 times 2 times 2 is 8, and it can be somewhat useful there also, figuring out exactly how many you have. I will say this about coming up with arrangements of items like this. Anything beyond 3 is a real chore, and we have special technology that deals with that actually quite well. Our goal here is to understand what's happening. So this is really as far as we'll take this. All right, so there is the end of my discussion on tree diagrams. I'm going to stop my recording. Thank you.